Today we are discussing the topic arrangements and selection. Arrangements and selection means permutation combination related topic we are discussing today, and when to use permutation, when to use combination, I will explain in detail in today's class. In probability chapter also I have shown you this flashcard where we discuss the probability basic facts with this flashcard, and for permutation combination or selection or arrangement problem, these facts will help you. R things can be selected from N things in NCR ways. That is very important to know. For example, if in this class there are 40 students, I want to select 2 people from this class randomly. So how many ways I can do? 40C2 ways. And if you don't know what is 40C2, look at this definition, you will understand. School day math itself, if you have forgotten it, please try to recollect it or remember it or learn this. NCR is n factorial divided by n minus r factorial into r factorial. That means 40C2 will be 40 factorial divided by 40 minus 2 factorial into 2 factorial. That is how mathematically you can write. 40 minus 2 factorial means 38 factorial. 38 factorial into 2 factorial. Finally, you will get it as 40 into 39 divided by 1 into 2 after cancelling the common terms. So, in this kind of a case, you don't have to write that full value or full expression. In school days, you have learned a shortcut. If you have forgotten, I will remind you. If it is 40C2, you just write 2 numbers starting from 40 in decreasing order. And as it is 40C2, due to the 2 in the bottom also write 2 numbers starting from 1. So that will be 40C2. So if it was 40C3, similarly you have to write 3 numbers starting from 40 in the decreasing order. And in the bottom you have to write 3 numbers 1 into 2 into 3. This was the shortcut you learned in school days. That is NCR, or that is a definition of combination. 10C2, look at this. 10C2 you can write the expression like this. But anyway, finally you are going to get the expression like this. 10C2 is 10 into 9 divided by 1 into 2. So that much is enough to write the answer or find the answer fast. If it is 10C3, it will be 10 into 9 into 8 divided by 1 into 2 into 3. And other properties of NCR, it is good to know. NCR and NCN minus R are equal. NCR, NCN minus R are equal. What does that mean? 10C8 will be equal to 10C2. That's a simple idea. 10C8 and 10C, 10 minus 8 are equal. 10 minus 8 is 2 now. So they both are equal. Or look at this example, 10C7 and 10C3 are equal. How does that help? For example, from this 40 student class, I want to select 38 students. Selecting 38 students is same as selecting 2 students. 40C2 and 40C38 are equal. This is looking easier to solve. That is why you can say that 40C38 is equal to 40C2. Logically, why they are same? Because selecting 38 people means I have to reject 2 people. For rejecting 2 people also, I have to select those 2 people and reject. Na? I mean, rejection also is kind of a selection itself. I am selecting 2 people and saying that I am rejecting them. That means selecting 38 people and selecting 2 people are same with respect to 40. Or mathematically speaking, NCR and NCN minus R are same. NCR and NCN minus R are same means NC1 and NCN minus 1 are also same. And NC1, NCN minus 1 are both N. For example, 10C1 is equal to 10. Always NC1 is N itself. 10C1 is 10, 20C1 is 20, 30C1 is 30, etc. And 10C1 is same as 10C9 due to the fact we discussed. And what is NC0? That is what this fact is saying. NC0 is same as N, because NC0 and N are equal. Sorry, NC0 is same as 1. NC0 and 1 are equal. NC0 is same as NCN minus 0, NCN. So NCN is also 1. That means 10C0 is 1, 10C10 is also 1. And I will show you how this will help you in CSIR-NET questions, this combination concept. So that is about combination. Now permutation, if you want to know, denoted by P, NPR is equal to n factorial divided by n minus r factorial. That is the definition. N minus r factorial. If there was one more r factorial, that is NCR. That means NPR divided by r factorial will be NCR. Because look at this definition, there are only extra thing is r factorial. Na? But fortunately you don't have to, because in permutation and combination is always confusing. When to use permutation, when to use combination. That is why I will say a simple rule. Forget about permutation. For CSIR-NET perspective, only combination is needed. Permutation questions, I will tell you a better way to do rather than using permutation. A logical way to do, I will explain. So, I will show you a first question which was asked in CSIR-NET. If I am remembering it right, this was asked in June 2016, this was asked. In a group of 11 persons, each shake hand with every other once and only once. What is the total number of shake hands? Those of you who watch this movie, Super 30 movie, in the Super 30 movie there is a problem much similar to this. There are 30 people in a group. So the hero, this Hrithik Roshan is asking how many handshakes are done between all the 30 people. So this is the same question. Instead of 30 people, it is 11 people. So you can do it in different ways. First I will tell you the mathematical approach, then I will tell you the logical reason behind why it is working. For 11 persons, you have to select 2 people for a handshake. Na? Why 2 people? Because only if 2 people are there, you can make a handshake. That means it is about selecting 2 people. Whenever it is selecting, we are using combination. That is what we discussed in this fact. R things can be selected from n things. For making a handshake, you have to select 2 people. Order does not matter, only selection matters. When order matters, that is when permutation should be used. So, from 11 people to select 2 people, how many ways are there? That will be equal to the total number of handshakes done by every other once and only once. That means only one handshake between 2 people. That is why 2 people selected, 1 handshake done, they 2 are done. Next 2 people, another handshake. Next 2 people, another handshake. So total number of handshake will be 11C2. That's a simple idea. 11C2 is 11 into 10 divided by 1 into 2. That is 55 is the answer. Very simple if you know this theory. Now, mathematically I told you use C. But why use C or why that is correct? That I will explain now. Think that 11 people, I will call them A, B, C, D up to K. K is the 11th letter. So up to K, 11 people. A will handshake how many times? Number of handshakes done by A you can find. Number of handshakes done by A. Number of handshakes done by A is 10 in number, because 10 other people are there. A will not handshake with A itself. A will handshake only with the remaining 10 people. So total number of handshake by A is 10. Total number of handshake by B is also 10, but there is a twist. A and B already handshaken. When A handshaken with B, B already did that handshake. That one handshake is AB handshake and BA handshake. Their order does not matter. AB handshake, BA handshake are not different. They are the same handshake. So one handshake is enough to complete A and B pair. That means in the list of B, you cannot add 10. You can add only 9 handshakes to the list, remaining list. Because A and B's handshake already counted in this 10. So B will handshake only 9 more handshakes. Distinct handshakes is what we want. Now think about C. A already handshaken with C. B already handshaken with C. That means C only have to handshake with the remaining 8 people excluding A, B and C himself. So that means 8 handshakes by C. Similarly D will handshake 7 times, E will handshake 6 times, up to last person K will handshake 0 times, because normally they will handshake with all others. Na? Already all others came and handshaken with K, so K don't have to go anywhere and handshake with any other person. J will handshake to one person, that is K only, because all others already came to J and handshaken. That means 10, 9, 8, 7, then 6, 5, 4, 3, 2, 1, 0 will be the order of handshakes. That means total number of handshakes will be adding up all these handshakes. In between there are 6, 7, 6, 5, 4, 3, all are there. So total number of handshakes will be 1 plus 2 plus 3 plus 4 plus up to 10. 0 is there, but that does not matter. That is sum of first 10 observations. Sum of first 10 observations is 10 into 11 by 2. Sum of n natural numbers is n into n plus 1 by 2. Same idea. Look at this, 10 into 11 by 2 is also 55. This is same thing now. 11 into 10 by 2. 10 into 11 by 2. Both are same. So logically, if you count also, you will get total number of handshakes as 55 itself. Otherwise, logically speaking, one more way you can interpret it in a broader way. Every person will handshake not to himself but to all others. So 10 handshake. That means 10, 10, 10, 10, 10, 10 total. 10 into 11 handshakes should have been there. But half of them are repetition. AB is repetition, AC is repetition, AD is repetition. Half of them are repetitions. So you can say 11 people handshaking 10 times. So 11 into 10 by 2. By 2 because to avoid the repetition. That way also you can think. Again, even if you don't understood that, it's okay. I hope you understood the first two methods. That is more important. When to use combination, if you understood, you can do it very fast. So NC2 idea, if you understood here, as it is 11 people, 11 C2. If it is 20 people, 20 C2. For handshake, this is the case. For all the questions, this may not be the case according to the situation. When order does not matter, that is why we are using combination. When order does matter, you have to use permutation obviously. But without permutation, how to do, I will explain. Anyway, try the next question. All of you try the next question. This is a practice question, similar to the previous question. So this question, in a party with 8 persons, each exchange gifts with each other. Gifts with each other, you should understand that scenario. It is not exactly same as handshake. Because handshake, when one person is handshaking to other person, they both handshake are already done. But when giving gifts, that is not like that. Na? You giving gift to your friend will give another gift to you. That is the meaning of exchanging gift. Na? Not giving only gifts, it is exchanging gifts. So, for example, A giving gift to B means B will give another gift to A. That is the meaning. So definitely here, if you calculate A, B, C, D, E, F, G, H, I, J, H, I, E, F, G, H, if they are the 8 people, A will give 7 gifts because there are 7 people remaining. 8 people means 7 people remaining. B, C, D, E, F, G, H. B will give 7 gift itself because B have to give a return gift to A. A giving gift to B, B giving gift to A are different. Order matters. When order matters, you can use permutation. But as I told, even if you don't understand permutation, logically you can do like this. So A7, B7, C7, D7, all of them are 7. So once you understood that 8 people giving 7 gift each means 8 into 7, 56 is the answer. So simple a question. Or we can say n people, they have to give n minus 1 gift each. So n into n minus 1 will be the idea. But in the shake hand problem, it is n into n minus 1 by 2. If n is the number of people. So n into n minus 1 by 2 will be the answer. So according to the situation only you can find the answer. Again, permutation, if you want to know more about permutation, you can use permutation idea. 8 people are there and how many ways order matters? 2 ways order matter. So 8p2 will be the answer. That also will give you the same answer. 8 factorial, sorry, one second. 8 factorial divided by 8 minus 2 factorial. That is permutation. Na? 8 factorial is 8 into 7 into 6 factorial and the bottom part is 6 factorial itself. 6 factorial cancels, you will get the same 56. When ordering matters, you have to use permutation. When ordering does not matter, you can use combination, like in the shake hand problem. So I hope all of you understood that. If so, in this question, railway route question, their ordering matters or not, you should understand. Then you can use the either permutation combination or the logical idea that how many are there and count it totally using multiplication. If there are 10 stations on a railway route, the number of different journey tickets that are required by the authorities. For example, I will take Delhi to Kerala or Delhi to Cochin Rajdhani Express. Between that, there are only 10 stations. So, how many tickets the authorities should make? For example, Delhi to Cochin or any place, I am just calling A, B, C, D, 10 spots are there. So from A, there will be 9 tickets. Why 9 tickets only? Because A to A ticket will not be there. A to B, A to C, A to D, up to A to J, 9 tickets. From B, B to A return ticket is another ticket. You will not be allowed to give Delhi to Agra. With the same ticket, you cannot go back Agra to Delhi now. So that is a different ticket. So here ordering matters. Ordering matters means permutation, not combination. Arrangement it is. A, B, B, A are two arrangements. When there is a need of arrangement, you have to use permutation. That's a simple idea. Again, I will say, if you forget permutation, no problem. Logically, you can do like this. A, 9 tickets. From B, 9 tickets. From C, 9 tickets. D, 9 tickets. All the 10 stations have 9 tickets to be issued. So 10 stations with 9 tickets means 10 into 9, 90 tickets. Or 9 plus 9 plus 9 plus 9 plus 9 added 10 times is 10 into 9, 90. Na? Or here also we can say n into n minus 1. If you are not okay with the permutation formula, this is the easy way. If n stations are there, every station have n minus 1 tickets to be issued. So n into n minus 1 tickets totally. Permutation if you use also, you will get the same answer. 10 stations are there. And we are considering 2 stations at a time and ordering matters. That is why P. If ordering does not matter, C. So here ordering matters, so 10P2. If it is only forward ticket only, for example Delhi to Cochin only, if you are only thinking about the forward journey, then 10C2 would have been the answer. Here it is forward and return, because from the perspective of authorities, they have to think about the forward journey, backward journey both. Na? So it is 10P2. 10P2 if you do, you will get 10 into 9 divided by 10 into 9 divided by 8 factorial. 10 into 9 into 8 factorial divided by 8 factorial. Once you do it and simplify it. That is same answer 90 itself. So whichever way you think, it is easy, these kinds of questions. Where to use permutation and combination should be clear. So I will show you another CSIR-NET problem from the same topic. Try this question. Anusuya, Raghunandini, Anusha, Prajakta, Roshna, Karpe, Nadasha also. So happy to see more people responding. Very good. So this question, during summer vacation of 20 friends from a hostel, each wrote letter to each of all others. Sending letter, how it is? A, B, C, D up to 20 people till T. A sending letter to B, that means B send another letter to A. So order matter, AB is one letter, BA is another letter. When order matters, simply speaking, if you are thorough with the permutation idea, 20P2. 20P2 is 20 factorial divided by 20 minus 2, 18 factorial. When you cancel it, you will get 20 into 19. 20 into 19, 380 is the answer. That is a mathematical explanation. But logically, what is the idea? That also we will discuss. A will send how many letters? A will send 19 letters, because there are only 19 people remaining. A will not send letter to himself or herself. A will send to others only. Each wrote a letter to each of all others. B will send letter to 19 people, because B will send letter to A also, and the remaining 18 people. 18 plus A, 19 people. C will send letter to 19 itself, D will send letter to 19 people itself, up to all the 20 people will send letters to all the 19 others. So 19, 19, 19, 19 added 20 times. Multiplication is repetitive addition. Adding 19 20 times is called 20 into 19. 20 into 19 is 380. So the answer is 380. Option D is the answer. If the question was saying that A will send letter to himself or everyone will send letter to themselves also, then 400 would have been the answer. So anyway, option D is the answer. This is the logical idea. A sending letter to 19 people, B sending letter to 19 people, C sending letter to 19 people, etc. So 20 into 19, 380. So I hope you all understood a general idea. Permutation type of problem. Again, even if it is permutation type, if you are not very confident with NPR formula, don't use it. Logically do it. That is enough. Because another set of permutation type problem is for letter arrangement. There also without permutation formula itself you can find it if you individually think what is happening there. So anyway, now I will go to combination, when to use. Combination we already discussed in handshake problem. This is a very straightforward example of a combination problem. Please try this, all of you. Okay, so I'll start explaining. This is a typical example where you have to use combination formula again, because it is selecting. From 5 men, you have to select 2 men. Selecting 2 men means 5C 2 ways are there. From 5 things to select 2 things, 5C 2 ways are there. Now from 6 women, you have to select 3 women. 6 people selecting 3 people, 6C 3 ways are there. But this is at the same time, and in the probability class we discussed, whenever and is coming, you can use multiplication. Here also you can use multiplication, because and means using fundamental principle of counting is the reason. M things you can, M ways you can do one thing, N ways you can do another thing, M into N ways you can do both the things. Huh? So 5C2 into 6C3 ways you can do both. So 5C2 is 5 into 4 divided by 1 into 2. 6C3 is 6 into 5 into 4 divided by 1 into 2 into 3. 1 into 2 into 3 and 6 can be cancelled. 2 and 4 can be cancelled to get 10. That is 10 into 20. That is 200 will be the answer. Just given this question, just to give you an idea. So option B is the answer. They can twist this question more, but CSIR-NET exam they haven't asked much twisted question from this topic. They can ask like, what is the probability of, how many ways that at least 2 men will be there, or at least 3 women will be there. There you have to think, at least 3 women means 3 women, 4 women, 5 women, 6 women, all are possible. But as CSIR haven't asked that, I am skipping that. Anyway, for that also, you just have to find the probability and add, find the arrangement and add it. And in a probability way also this question can be asked. In the probability class we discussed a combination related probability problem where numbers are selected and adding up to 20. There from 15 numbers you have to select 2 numbers. 15 C2 ways are there. There successful outcome divided by total outcome you have to do. Both of the numerator and denominator you have to use combination. That's the only difference. Again, as CSIR haven't asked much about those things, I am going to the next type. This is the next type, letter arrangement type. This is very important because CSIR also have asked this topic before. Make an attempt, all of you. So here, in how many different ways can letters of the word years can be rearranged? I will explain with a small example. If the word was ask, A-S-K, ask, a 3-letter word. How many ways, different ways the letters of the word can be rearranged means, I will write all the rearrangements so that you get a proper idea. A-S-K, A-K-S, S-A-K, S-K-A, and K-A-S, K-S-A. These are the 6 ways. So in this case 6 is the answer. But mathematically you cannot do it for the bigger cases now. Writing all the possibilities is not possible. Because for example in this question answer is 120. Writing all the 120 combinations are not possible. So we have to understand the theory. Understand the theory means here you are fixing the first letter first. fixing first letter itself have 3 varieties, because 3 letters possible means the first letter can be any of the 3 letters A, S, K. For this question, A, S, K. That means 3 possibilities for the first spot. But if you look at it, the repetition is not allowed here, because you are taking that letters only and rearranging. Rearranging means you cannot add it one more time. You cannot say A is a possibility. No. So definitely once you use A here, you cannot use that anymore. So in the second spot there are only 2 letters remaining. So 2 possibilities in the second spot, either S or K. Look at this. Yeah, if you are fixing S in the beginning, either A or K. If you are fixing K in the beginning, either A or S. So definitely once you fix the first letter, there are only 2 possibilities for the second letter, because they are the only 2 remaining possibility. Now once you fix these 2 letters, the third position can be only occupied in one way, because first 2 spots fixed, there is only 1 letter remaining, so only one way. And if you can do one thing in M ways, another thing in N ways, another thing in P ways, 3 things together can be done in M into N into P ways. Fundamental principle of counting again. This rule we discussed in probability chapter is we are using here also, or simply speaking, when it is AND, you can multiply. Why AND? Because the ways in which you can fill the first spot and second spot and third spot at the same time. So we are multiplying. So 3 into 2 into 1 is 6. Or we can say mathematically 3 factorial, or in general we can say if it is n letters, n factorial will be the idea. For letter arrangement question, n factorial is the idea. I hope all of you understood that n factorial will be the idea. Now n factorial is the idea means here n factorial there are some exceptions, about that I will explain. Here all the letters are different, that is why we can use this n factorial idea. If one of the letter were repeating, there is an exception, or you have to do a little more thing. So anyway, if there are 5 letters, 5 factorial, years have 5 letters, so 5 factorial will be the answer. 5 factorial means 5 into 4 into 3 into 2 into 1. That is 120 is the answer. Option D, 120. Now another twisted way the same question can be asked is like this. Same word years itself. How many ways it can be arranged in such a way that the vowels can come together in this? Vowels coming together means, you know, the vowels are here E and A. A, E, I, O, U are the vowels now. So E and A coming together. E and A coming together means E and A consider a single letter. That is the simplest understanding. E, A consider as a single letter, as a group. Now how many letters are remaining? Y, R, S, 3 letters. That means in total there are 4 letters. In total, EA is 1 letter, Y, R, S. If 4 letters are there, definitely 4 factorial arrangements will be there. First spot can be filled with the letter EA or Y or R or S. Second spot can be filled with the remaining 3. Third with the remaining 2 and fourth with the remaining 1. So anyway, 4 factorial arrangements. But 4 factorial is not the answer, because EA internally can be rearranged in 2 factorial ways. EA can be rearranged in 2 factorial means 2 ways. Why? Because EA is one arrangement, AE is another arrangement. That is also vowels together. Na? That means for this 4 factorial possibility, there are 2 factorial times or 2 times you can write that. Simply speaking, these kinds of question you can do internal arrangement into external arrangement idea. Internal arrangement means those letters that you are coming together, that coming together, how many ways internally they can be ordered, because here order matters. Into total all the letters. EA consider as 1 letter, totally how many letters? 4 letters. That is external arrangement. You are 2 factorial and 2 are same, that is why here writing 2 is okay. But when there is 3 vowels, 3 factorial you have to do, not 3 into, it should be 3 factorial into. That means the final answer is going to be 2 into 4 factorial is 24, 48 will be the answer, option C. Now the third way the same question can be asked is, vowels cannot come together. Vowels can come together is 48. Na? In the first case I told you vowels, total possibility is 120 we understood. The word years can be rearranged 120. In that case, vowels together possibility is 48. So vowels not coming together will be 120 minus 48, 72. Like the complement approach we learned in probability, you can do it. Total minus vowels coming together will be vowels not coming together. Total is 120 minus vowels coming together 48. 120 minus 48 is 72. So the answer is option A, 72. So instead of finding vowels cannot come together, find vowels come together case, subtract it from the total. So this is a CSIR-NET problem from the same topic. Try this. The word chance, C-H-A-N-C-E, there are 6 letters. 6 letters means 6 factorial should have been the answer, 720. But there is a problem because here one letter is occurring twice. C is occurring 2 times. Due to that, there are many repetitions. That repetitions are included in this 720. That repetition should be deleted. Repetition means if you put C, this C and this C, if you interchange, will that make a new word? No, they are the same word. Due to that, there are many repetitions happened. So to divide, to find the final value, the simple idea is you can just divide by 2 factorial because C is occurring 2 times. So divide by 2 factorial. So if there are n letters and one letter is occurring r times, n factorial by r factorial is the idea. That means 6 letters here, one letter C occurring 2 times. So 6 factorial by 2 factorial, 720 by 2, 360 will be the final answer. 720 is not the answer. 720 would have been the answer if the word was change, not chance. Because change, there is no letter repeating, distinct letter only, it would have been 6 factorial. If one letter occurring 2 times, you have to divide by 2 factorial. If one letter occurring 3 times, what you have to do? For example, if it is success. So, if it is success, here there are 2 letters repeating. 1, 2, 3, 4, 5, 6, 7. 7 factorial divided by 2 factorial into 2 factorial you have to do. Because C occurring 2 times, S occurring 3 times. Sorry, not 2 factorial into 3 factorial. Because this S is occurring 3 times. Due to that, you have to divide by 3 factorial. Some more example I will give you. If it was the word Indian, or we are at India, first I will explain. Then it will be 5 factorial divided by 2 factorial because I is occurring 2 times. If it was word Indian, then it will be changing to 6 factorial divided by I occurring 2 times, so divide by 2 factorial. N occurring 2 times, so divide by 1 more 2 factorial. So that is the idea of these kinds of questions. And this was a previous CSIR-NET problem. So there are some more types of problems, some more CSIR-NET problem that we will discuss in the next class.